Hello everyone. In today's video, we will walk through implementing a real-time data streaming pipeline using Kafka. In this video, first we will create a Kafka producer to generate a mock stock price data and stream it into a topic. Then we will build to Kafka consumer to read from that topic and perform real-time analytics, including detecting price anomalies. We will see how Kafka enables rapid data movements and processing, making it perfect for real-time analytics sample application. So let's get started. First thing first, we need to start our Zookeeper and Kafka server. This setup provides the backbone for managing a distributed Kafka cluster. So let's run this command to initialize both services. Zookeeper-server start.sh space dollar Kafka underscore home slash config slash zookeeper dot properties. Now let's open another terminal to start Kafka server. Kafka server start.sh space dollar Kafka underscore home slash config slash server dot properties. Now let's check the list of Kafka topics. So that let's open a new terminal and type set path first cd space slash usr slash local slash Kafka, enter, then bin slash Kafka hyphen topics.sh space hyphen list space hyphen bootstrap hyphen server space localhost colon 9092. Here you can see the Kafka topic names raw data. Alright, now let's get into our producer code. The Kafka producer will generate synthetic stock price data for the symbol AEPL and push it into a Kafka topic named raw data. This is where our streaming data comes to life. Before moving towards the code, let's first import necessary libraries. We are importing producer from the Confluent Kafka library to handle data streaming. Then we import JSON, import time, and import random library. Now let's define the delivery report function. The delivery report function will confirm whether each message was successfully sent to Kafka. This function will be used as a callback for our Kafka producer. Every time a message sends, it will automatically check if the message was successfully delivered or if there was an error. Here we check if there an error in delivering the message. ERR will contain error information if the delivery failed. If an error occurred, this line prints out a message saying message delivery failed, along with the error details contained in ERR. This lets us know exactly what went wrong in the delivery process. Now if there was no error, we move on to the else block. This means our message was successfully delivered. Here we print a confirmation that the message was delivered. This line shows us the exact Kafka topic given by msg.topic function and the partition within that topic shown by the msg.partition function. This is useful for verifying exactly where our message ended up in Kafka. In this line, we are creating an instance of the Kafka producer class, which allows us to send a message to Kafka topics, and the producer is a core component of Kafka's API, enabling us to produce or push data into Kafka. Here we are defining our generate data function. This function will create and send mock stock price data to Kafka, simulating a live stream of stock data. We start within an infinite while loop, meaning this function will keep generating and sending data infinitely. This is useful for simulating continuous data in real time. Inside the loop, we create a dictionary called data with 3 key value pair. Symbol, this is sent to AAPL represent the stock symbol. Then price, here we use random.uniform function in parameter 120 to generate a random price between 100 and 200. And the round function limits the price to 2 decimal places. And timestamp, we generate a timestamp in milliseconds using time function multiplied by 1000. This gives us the exact time when the data was generated, which is useful for tracking. Next, we send this data to Kafka using the producer.produce method. We specify raw data as the topic name where the data will be sent, and the key is set to stock sequence AAPL, which helps Kafka route message to specific partition. For the value, we convert data dictionary to a JSON string using json.dumps function data. Finally, we use callback equals to delivery underscore report, which calls our delivery report function to confirm if the message was successfully delivered. Then we call producer.poll function, which serves to handle delivery reports and other backgrounds tasks for the producer. This ensures the producer is managing its resources and keeping up with message acknowledgements. We add a print statement to display each message sent so we can monitor the data stream as it's generated. And finally, we include time.sleep function, which pauses the loop for 1 second between each message. This creates a steady 1 second interval for data generation, mimicking real-time updates. And finally, let's add our main function to run the producer. Now we have got our producer continuously generating and sending data to Kafka. Let's check the data on the terminal from topic. Here you can see the data. Now let's move on the consumer code. Our Kafka consumer will read the data from the raw data topic and calculate a rolling average of the prices. It will also detect any price anomalies based on the average. So here first we importing 3 components from the Confluent Kafka library: consumer, Kafka exception, and Kafka error. Consumer allow us to create a Kafka consumer which we will use to read and process message from Kafka topic. Kafka exception and Kafka error are used for error handling in Kafka. If our consumer encounters any issue, these help us catch up and manage errors in a structured way. Next, we import the JSON library. This will let us handle JSON data, which is useful because messages sent to Kafka are often serialized in JSON format. We will use this to convert data from JSON string to Python dictionaries for easier processing. We also import statistics, a standard library module that provides tools for statistical calculation. We will use it later on to calculate metrics like average, which is key for real-time data analytics. And lastly, we import DQ for collection module. A DQ or double-ended queue is a specialized list and lets us quickly and add remove elements from both ends. We will use it to maintain a rolling window of data points, which is perfect for calculating moving average efficiently. Here we are setting up a consumer configuration dictionary that will define how our Kafka consumer connects to the Kafka server and handle incoming messages. Bootstrap.servers, this key specifies the Kafka server address. In this case, we are using localhost :9092, meaning the consumer will connect to a Kafka server running in our local machine on port 9092. The group.id, this is unique identifier for our consumer group, which we have set to real-time analytics group. Consumer groups allow multiple consumers to work together by splitting up the data within a topic. Each consumer in the same group processes different messages, making data processing efficient. And auto.offset.reset, this setting tells Kafka where to start reading message when the consumer has no previously stored position or offset. By setting it to earliest, we ensure that the consumer begins reading from the start of the topic. If it's a new consumer, this is useful for seeing all past messages, which is helpful for testing or debugging. Here we create a Kafka consumer instance using the consumer config dictionary we set up earlier. This consumer will connect to the Kafka server and listen for message from the specific topic. Next, we call consumer.subscribe with a list of topics. In this case, just raw data. This tells the consumer to start listening to the raw data topic, where our Kafka producer is sending messages. Every time a new message is available in this topic, our consumer will receive it. Now we create a new queue called a rolling window with a max length of 5. This DQ acts as a rolling or sliding window to hold the most recent 5 data points. By keeping the last 5 values, we can easily calculate a moving average and detect any anomalies in real time. When a new data point comes in, it pushes out the oldest one, keeping the window up to date. Here we define a process message function, which is responsible for processing each incoming messages from the Kafka topic. This function will decode the message, calculate a rolling average, and detect anomalies in the data. First, we use JSON.loads function and message.values function to parse the value which is in JSON format. This converts the JSON string into a Python dictionary called data, so we can easily work with its element. Next, we extract the price from data dictionary. This price value represents stock price we will analyzing. Then we add the current price to our rolling window. This DQ store only the most recent 5 prices, which is helpful for calculating a moving average. Now we check if rolling window is full by comparing its length to max length only when we have full set of data points. 5 in this case, we calculate the rolling average. When we calculate the rolling average by summing up the values in rolling window and dividing by its length. So this average provides us with a baseline for detecting significant deviation in price. Next, we check for anomalies. We compare the absolute difference between the price and the rolling average. If this difference is greater than 10% of rolling average, we flag it as an anomaly. And if the difference is large enough, we mark it as an anomaly by setting true. Otherwise, if the price is within the acceptable range, we set it false. And finally, we print out the data dictionary, which now includes the anomaly flag. This output allows us to see each data points along with its anomaly status. If rolling window doesn't it have 5 data points, so we simply print the current data without calculating an average. This way, we know when there is not enough data for analysis. In case there an error in decoding the JSON message, we catch it except block. We print an error message if JSON decoding fails. This is helpful for debugging if our messages aren't in the expected format. Here we define the consume data function. This function handles the main loop for our Kafka consumer, allowing it to continuously poll for new messages in the Kafka topic and process them as they arrive. We start with a try block and a while loop, which keeps the consumer running indefinitely. This loop will allow the consumer to poll Kafka for a new message continuously. Inside the loop, we call consumer.poll function time equals to 1.1 set. This method checks the Kafka topic for a new message within 1 second timeout. If there's no message within this time, it returns none, allow us to avoid unnecessary delay. Here we check if message is none, which means no message was received. And if that's the case, we use continue to skip the rest of the loop and poll again. Next, we check if the message contains an error. If message.error function is true, that means something went wrong with the message retrieval. And we handle one specific error type here, underscore partition underscore EOF, which signals the end of a partition. This error isn't critical, so we use continue to ignore it and move on to the next poll cycle. If the error is something other than underscore partition underscore EOF, we print the error message. This helps us identify other issues that might need attention. Then we raise a Kafka exception for any error that aren't partition EOF. This allows our program to handle unexpected issues that require more immediate intervention. If there are no errors, we pass the message to the process message function, which handles the data processing, and this is where each message will be analyzed for rolling average and anomalies. And finally, in the final block, we call consumer.close function. This line ensures that the consumer is properly closed and resources are freed up when the function exists, either due to an error or when the program ends. And at last, we write a main function to run the consumer code. Now, before running this code, let's run a producer code to run this and then run this consumer code. Alright, now that our code is running, let's take a look at what's happening here in the output. In producer code, we saw the output from Kafka producer, which is continuously generating and sending stock price data for the symbol AAPL. Each message includes a randomly generated price and timestamp simulating real-time stock updates. And here the output from our Kafka consumer, as each message comes in the consumer calculator routing average and checks anomalies. When the price deviation is greater than 10% from the average, it's flagged as an anomaly. So in this video, we walk through setting up a Kafka producer to simulate a stream of stock data and a Kafka consumer that process this data in real time, calculates rolling average, and flags any anomalies. This setup is a powerful example of how Kafka can be used for real-time analytics, from data generation to immediate processing and analysis. So thanks for watching. See you in the next video with next topic.